Hi, how are you all doing today? I'm giving a brief introduction and a proof of what's known as the Pythagoras theorem. The Pythagoras theorem says if you have a triangle with a right angle, 90 degrees, the two smallest sides squared and added will equal the longest side squared. It's also known as the hypotenuse. So if we measure this number and squared it times by itself, we measure that side and then square it. We add those two totals. It will be the same answer as that third side squared. Okay, and that's for any triangle with a right angle 90 degrees. I drew three of them to show there are many types of triangles with 90 degrees. And how is this useful? Well, the whole point is mathematics is a tool for solving problems. Let's say you have a building. We know the height of the building, and we need to connect a wire from a particular point to the top of the building. And it's difficult to measure from this point to that point. But if we know this distance and we know that distance, we can use the Pythagoras theorem to calculate how long that wire should be. Now, the purpose of this is to prove the theorem. Later on, I can always give numbers to show how we can use it to solve problems. There are many proofs out there. I'm going to show you what I consider one of the most simple proofs. Okay, one thing about proofs, very often we prefer to use algebra or letters rather than numbers. Because if I demonstrate something with numbers, one can say, well, you've shown that it's true with this particular number, but does it mean it's always true? While using letters or algebra, we show it's true for any numbers. What I do is I draw a perfect square, all right? In that square, I draw another square, and I keep these little distances the same. That ensures that if I divide each side into A and B, where A is the shortest side, A is the shortest segment and B is the longest segment, that A and B will be the same with all four sides. That means these points will all be the same distance from each other because it's in proportional. Like this point is proportional, same as this point to that point. So we have one square within another square. Now, and I happen to call these little segments A is the smaller one and B is the bigger one. Now, logically, the area of that big square will equal the area of the small square and the four triangle areas added together. Okay, this big area is the same as this small area plus these four triangles areas will equal the big area. Okay, I wrote it there. Big area equals the area of the big square equals the area of the small square plus the area of the four triangles. Well, what's the area of the square? It's side times side, A plus B times A plus B. There it is. Now, what about the square in the middle? I call each of these sides C. So C squared is the area of the inside square. And a triangle, seeing that's a 90 degrees, would make B the height. Area of a triangle is half times A times B. So 4 of them is 4 lots of half AB. There's 4 lots of half AB. Okay? So there's our equation. A plus B times A plus B. Area of the big square equals C squared. That's the area of the small square plus 4 lots of areas of the 4 triangles. Okay, using algebra, we multiply that out. A squared plus AB is 2AB plus B squared equals C squared. 4 times a half is 2. So 4 times half AB is 2AB. We have an equal sign, two equations. Always think of a balancing scale. If you have a balancing scale, then each side is the same weight. If I remove the same amount from each side, it will still be equal. So what I can do is, if I remove 2AB, oops, it's not balancing. I've got to remove 2AB from here. So if the previous equation is true, the new equation will be true. And what do we get? A squared plus b squared equals c squared. If that's 90 degrees, a squared plus b squared equals c squared. And I did it using algebra, which means it's true no matter what a and b is. And that is one of the most simple proofs I have found that proves the Pythagoras theorem to be true.